Alright, hi. Today in Algebra 2b we'll be talking about exploring periodic data. Okay, now periodic data is just basically a graph that repeats itself over time. Repeats itself over time. Okay? Alright, we'll talk about these three aspects of it, the cycle, the period, and the amplitude, as we actually look at some graphs, okay? Alright, so just taking a look at it on Desmos, here's an actual graph of a function. I'm not going to talk about what this function is. One thing you do need to understand is that sometimes your graph settings up here in the right hand corner must be in degrees, and sometimes it must be in radians. In this case, radians is most helpful for this graph. So just be very careful as you go along. Okay, now in this graph, when we're talking about amplitude, we're going to talk about the height of the actual function. Okay. Now, this is going to be a little bit funky in these terms, okay? But if you check out the height, the height is going to be the distance between the top of the wave or the top of the actual function, the periodic function we're looking at, and the bottom. Okay, and I just realized that periodic function, it's going to be a repeating pattern. So as you can see, we're going up, we're going down, we're going up, and it doesn't matter where you pick. You could pick between here and here, and just look at this information in here. Okay, and as you can see, as it goes from this top point and it goes down into the curved valley and then goes back up, it starts again to where it's going to go down. I mean, it looks like Tiny Wings, that little cool game you play on your iPhone. Or you could look at your reference points as the middle of the actual hill. So starting here, we're going up, and then we come down, and then we start to go back up to the top again, and you can look at the distance between those and just work with it that way. But as you can see, it's a repeating pattern. Okay, let's take a look at the different graph. This one's similar, okay, except it starts right here, goes to right there. Okay, and just some really cool stuff as you just work with it. So this is also a periodic function, and we'll be taking a look more closely at this curve and calling it a certain name later. Alright, now in this one here, this may not look periodic because it doesn't look like an exact function, but it is because it's repeating the same pattern. It doesn't have to all be one curve as we go. But as you can see, if I pick a point here and then I go up, okay, and then I start from down low at the probably negative infinity and then come back up, I'm going to come up to the same spot where it's an x-intercept. Okay, so what I like to do is look at the x-intercepts as my period, as what I'm working with. Okay. All right. Now on these previous graphs, you can tell the height was actually about from 1 to -1. So this amplitude is about a 1. Okay. All right. Whereas with this one, I can't measure it because it goes on for infinity. So I'm not going to mess with it too much. Okay. Now I did want to talk about the actual period. Okay, and the period is how long it takes to actually go about a length of one wavelength. And in this case, this is going to be about 2 pi. Okay, as you can see, it goes from -2 pi to 0, or from 0 to 2 pi. It doesn't matter where you look, as long as you look in the same spot in the periodic function on each graph, you will see the same distance. Okay, now if I were to pick my x-intercepts as the points of what I'm looking at, okay, this distance right here is also 2 pi, and same thing with right here. This distance is also 2 pi too. Okay, now if you were having a hard time seeing that, just subtract the two and you'll be able to see it a little bit better. Alright, now this one is a little bit more interesting. Okay, if you notice from here to here, the x-intercept, we are repeating the same one after this. So this period would actually be about pi. Okay, now its amplitude is undefined because it goes on forever, but this period is actually going to be pi for this periodic function, okay? Alright, let's take a look at another one. Oh, once again, funky looking thing, but we can actually tell by looking at some of the information, we can actually tell that this is a periodic. Why? Because it starts here, it goes down into the valley, stays a little while, and then it comes back up, and it comes back to a peak. Okay? Alright, now some of you guys are probably wondering, how do I tell the amplitude and period of this? Okay, once again, amplitude is the distance between the y's, so between 3 and -1, that's about a distance of 4, so this amplitude is 4. And the actual period, I just need the two mountaintops. I'll just use that for this reference. You could use this and this. It doesn't matter which ones you use. It's going to be the same information. But anyways, this distance is about 2 pi. If I check down here, it might be able to be seen a little bit easier. This distance is pi, this distance is pi, so that's about 2 pi total as well. Okay, so once again, another periodic function. It looks a little bit funkier, and I'm not going to show you the graphs as much, but I just want you to focus on the periodic function parts. Okay. All right, now this one kind of looks like a tooth. Let me get this to be a little bit darker color. There we go. All right, so taking a look at this, it looks like a tooth and everything, and it's going to be kind of hard to see where we want to go. So you want to go to the highest point you can and then to the lowest point you can. So this distance is about 2.25. So this amplitude would be about 2.25 right here. Okay, now once again, it doesn't matter where you go, just don't do this as your period. This is not a period length here. You want to have a distance of about this far, because you want to go from where we start at one point and then we continue the same pattern at this point. So that's why I like to pick the highest or lowest points just to work with, just so that I understand, okay, this is a distance of about this is going to be about 2 pi as well, but I can see it much more clearly, whereas right here I'm kind of guessing what it's going to be at. It's like, I have to do the distance between those two, and you have to do the absolute value, that type of thing. Alright, now this one, it doesn't look periodic, but it is repeating a same pattern. Okay, it is repeating the same type of pattern. Now, the distances between these ones, I would take a look at the beginning of the graph, not the end. I wouldn't look at this as like, oh, it's going every pi or pi halves. No, no, that would be pi. It's going every pi on here. Nope, it's not. You want to not consider that. You want to consider you're looking in the same spot on each periodic function. Okay. All right. Alright, now this one's going to look really funky as we go, and it's actually a really cool graph that I made. But you would just look at these distances right here. They're not going to be exact and everything, so you are going to have to use the distance formula. In other words, you're going to take this number and subtract this number and do the absolute value of it. And the same thing here, subtract this and do the absolute value, and you'll be able to find the period and the amplitude of this function exactly. Now, as you can see, because it's repeating the same pattern over and over again, this is actually going to be a really nice working periodic function. It's not going to be a whole lot of fun to work with when you see the actual graph, but at least you can tell the difference on how to find the amplitude of the graph, and you can actually find the distances of for the period or that type of. I'm sorry. You can find the distance between the two troughs to find the actual wavelength or period, as you want to call it. Now, period is where one cycle happens, and amplitude is from the highest to the lowest. Okay, just so we can talk about it real fast, here's the actual formula. You take one point and you subtract another point and you do the absolute value of it, and you should be able to get the distance you want. Okay, all right, and that works for everything. That is it for exploring periodic data. Just make sure you're able to identify a periodic function type of graph as you work with it, and remember, they're going to have the same values at each point, the same y values. That's the most important thing. Okay, all right, that's it for talking about exploring periodic data. I'll talk to you later. Bye.